this session, we'll delve into what effective observability really means, exploring open-source technologies and specifications, like OpenTelemetry, that can help us to achieve this while ensuring our applications remain flexible and portable. Our expert is a Java champion and developer advocate at IBM. She builds POCs, demos, and sample applications, and writes guides and tutorials. She also has a keen passion for encouraging more women into STEM, and especially technology careers. Let's give it up for Ms. Grace Jansen.
Hi there, thanks so much for joining this session. Let me go ahead and share my screen. Fantastic. So hopefully you guys can see that. Please let me know in the chat if you can't see it at all. Thank you so much for giving up your time today to join this session. I see a lot of thumbs up. Thanks, guys. It's helpful. Thank you for joining this session on observability. Hopefully you're having a great time at the conference so far. It's fantastic to be able to join even here from the UK digitally. So it's great to be able to join you all. I have put a couple of polls into the polls section of this UI. So if you haven't already, please go ahead and check those out and please answer them. It does help me to be able to customize the talk to the audience, especially with the level at which you're familiar with these technologies. And I've also put a bunch of resources in the resource link. So if you see a link throughout the presentation, I've tried to make sure that there's at least a link in the resources page, so it's easy for you to be able to access those. And I've also linked to my slides in that as well. So if you do fancy having a look at them afterwards, then feel free to go ahead and click on those. So hopefully that will help if anyone wants to access any of the links that aren't there or any of the resources I've included throughout the slides as well. So without further ado, we'll get started. So yeah, my name is Grace Jansen. I'm a developer advocate at IBM based in the UK. I'm in Southampton, which is sunny today, which is nice. But I've been working at IBM as a developer advocate for the last 5-6 years. Before that, I did a biology degree, specializing in marine biology. So a little bit out there, a bit of a weird route into tech. So if anyone fancies having a conversation about that afterwards, feel free to reach out to me. So, and also if there's any questions I don't get around to, I will be looking at the Q&A section on this UI. So feel free to put your questions in there and I'll get around to them at the end. If I don't, or if you think of one later, or you just want to reach out and connect, then feel free to follow me on Twitter. My Twitter handle's at the bottom there, at GraceJansen27, or reach out to me on LinkedIn as well. So without further ado, let's get started. So through the looking glass, how do we achieve effective observability for our cloud native applications? Where does this phrase come from? Why have I used this phrase for the title of this presentation, through the looking glass? And really this is to do with, this sort of phrase was coined by Lewis Carroll way back when he created the books Alice in Wonderland. And this is actually the sequel to the original Alice in Wonderland book. You might be familiar, if you're not familiar with the book, you might be familiar with the newest Disney movie that's sort of fairly recently come out, Alice Through the Looking Glass. And in this story, Alice passes through a mirror, essentially a looking glass being an old-fashioned phrase for a mirror. She passes through this mirror over the fireplace and finds herself once more in this enchanted land where she originally found herself, Wonderland. So it's kind of this metaphor that Lewis Carroll used for being able to pass through a portal of some kind that enables you to go into this world of mystery and sort of upside downness almost. So if you're not familiar with this literature, there's also another sort of, this metaphor is used in another medium, in another film, and you may be more familiar with this film. So can anyone guess what it is from this? Yeah, we got a few hands, we got a few claps. Okay, so this is the Matrix. So actually in the Matrix, it basically refers back to the Alice in Wonderland phrases. They talk about when Neo gets woken up by his computer, it sends him a message saying, follow the white rabbit. He has to follow the white rabbit tattoo. They also say, you can take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. You take the red pill and you stay in Wonderland. and I show you how deep the rabbit hole goes. So there's this constant reference back to this original sort of coining of the phrase. But in this movie as well, they're passing through this mirrored surface, this portal, to be able to enter into a world, this secret world that he didn't know about before or wasn't able to see effectively. And this is kind of what we're trying to achieve when it comes to cloud native observability. We have this quite complex and often convoluted world of distributed cloud native applications. And sometimes it can be hard to be able to have effective visibility into that world to understand what's really going on. So what we want to do is build this portal, this looking glass, for us to be able to step through to better understand how our applications are behaving in this wild environment of the cloud. And so that's what we're going to try and focus on in this presentation today. How do we effectively build this looking glass, this portal? And why do we want to build it? So why is this important for us to build? Well, you might be familiar with this Disney movie. I'm a huge Disney fan. If you've not seen Toy Story, go and check it out. It's this excitement that we get as developers, this, ooh, the cloud, this excitement that we get about being able to utilize the benefits of the cloud, speed, innovation, flexibility, portability. That gets us excited as developers. So we want to be able to make use of it effectively. But how do we actually do that? And what does it look like in reality? Well, in reality, it doesn't always look as exciting as these aliens. Instead, what it can often look like is more like this. It's a bit frustrating. Often things don't work. Stuff doesn't go together. It doesn't work. It works on your machine, but it doesn't work in the cloud. So actually, it can be a lot more frustrating than we anticipate. And that's why it's important that when we are developing our applications, we can effectively see how they're behaving. Because if we don't know how they're behaving, we end up like this. So that's why this presentation is important, and the general topic of observability is important for us to be able to actually get past this frustration and understand and have a clear idea of what's actually going on in the cloud and go back to that excitement around utilizing the cloud effectively. Okay, so in this presentation, now that I've kind of introduced the topic, why it's important, why we're focusing on this, we're going to drill down into what do we actually mean by this phrase observability? How can we do this within our own applications? Delving into open source technologies and specifications and standards like OpenTelemetry, microprofile telemetry, and then utilizing a demo using OpenLiberty to be able to show just how easy it can be to get started with these technologies. And then at the end, we'll just sum it all up with some resources and sort of takeaways as well. Okay, so what do we actually mean by observability? And the reason that I've included this section in my presentation is because this phrase, this term, can often be quite broad and refer to many different things. So I just wanted to make sure we were all on the same page with a clear idea of what we actually mean by this term. So what is observability? In general, observability is all about how well you understand the internal state of something based on its external outputs. So it's all about having this high granularity insights into the behaviors of systems, along with having sort of rich context. So as well as having insights, we understand why those particular things are going on. But we can only do this by looking at the external outputs to understand what's going on internally. That's quite a broad description, so I wanted to be a bit more specific with this and really delve into, okay, what does that mean for us as developers in the world of IT and cloud computing? And what it means, really when you get down to the nitty-gritty, is observability is about utilizing either software tools or practices, whatever it might be, to importantly aggregate, correlate, and analyze performance data to be able to monitor, troubleshoot, and debug the application in the network. So it's those three key behaviors on either side. We want to aggregate, correlate, and analyze to be able to monitor, troubleshoot, and debug. And that's what we're trying to do within this presentation with these open source tools and technologies. So now that we're all on the same page in terms of understanding, okay, this is what we're trying to achieve. We're trying to aggregate, correlate, and analyze to monitor, troubleshoot, and debug. Let's take a look at how we can do that within our own applications. When it comes to implementing observability, if you think about it conceptually, it's actually fairly simple. To enable observability in our projects, there are three key steps in terms of the theory behind this. The first one of those is instrumentation. So we need to instrument our systems and our applications to actually collect relevant data, whether that's metrics, traces, or logs, whatever it might be. There's a vast array of different data we can collect. But if we're not setting up our systems and our applications to collect together that data, we won't have anything to be able to analyze or any insights because there's no data to base it on. So that's step one. Step two is, okay, now that we've collected this data, we need to export that data and send it to something that can store and analyze it. Remember in that first part of the definition, being able to aggregate and analyzing. So sending this data to a separate system, it might be something like you're using Jaeger or Zipkin or even the OTel collector for this. There's lots of different tools and technologies that are available that can help with exporting your data and being able to store and analyze it. But it's all well and good storing and analyzing it, but with reams and reams and tons of data, it can sometimes be hard if we're just looking at a spreadsheet of numbers to actually understand what's going on. So step three is vitally important, and that's to provide visualizations and key insights into our system as a whole. Being able to do things like query capability for our end user, and to be able to actually gain understanding from the data we're collecting. And this is kind of the final step. You might be using tools like, for example, Prometheus or Grafana or Kibana. These are all tools that allow you to be able to have monitoring and alerting, analytics, interactive visualization, and dashboards to be able to easily visualize what's going on in real time in your application rather than just staring at a bunch of numbers. So these, in theory, are how you would implement observability. But when it comes to practicality of actually doing this, that's when we start to get into more of the complications and where it can get a little bit hard. And so in this presentation, what we're going to do is just focus on that first step, on that instrumentation step. Because without this step, we can't really do any of the other two steps, like sending the data and providing visualizations. Because if we don't have any data, we're not going to be able to do step 2 and 3. For step 2 and 3, I've already mentioned some of the tools that you can make use of, like Kibana, Grafana, Prometheus. There's lots of different tools that are available for 2 and 3. And you can check those out afterwards once we've gone through the instrumentation part. But for this presentation, in the interest of time, we're just going to look at how do I instrument my own system and application to be able to collect data that I need. So focusing on this first step, to make a system observable, we have to instrument it. What do we mean by this? Instrumented means that the code should emit traces, metrics, and logs. These are what we call the 3 pillars of observability, hence this diagram. So these can help to make our system more observable and provide us with sort of powerful tools to be able to unlock the ability to be able to build better systems, because we understand potential bottlenecks or failure points, and we can then improve our own applications through this observability. Now, these are the 3 pillars that are utilized in many open source frameworks and standards that enable observability. However, there are obviously additional data or types of telemetry data that you might also want to collect, and these are being sort of pended as future additions to a lot of these standards. So examples of this might include things like end user monitoring. That allows us to be able to gain real-time visibility into the user experience. So we might be tracking the path of a single request and gaining insights as it's interacting with each service along the way. We might also take a look at profiling. So this allows us to be able to understand, where does our code spend the most time? Where are we using the most hardware resources? So things like memory, CPU, and we can really track that down to the individual line number to understand where in our code are we making, are we utilizing the most resources? Can we make that more efficient? At the moment, these aren't part of many of the standard specifications or frameworks, but it is hoped that in future they're going to be added. So for just now, we're just going to focus on logs, metrics, and distributed traces. So just to get a clear idea there. Just want to check if there's any questions so far. Not so far. Fantastic. So starting off with logs. Now, many of you are probably already familiar with logs, so we're not going to spend too much time on this one. But logs are obviously an important first step to instrumenting our application. Logs essentially are time-stamped messages, normally that provide sort of a higher level information about your system behavior. It might include something like an error or a warning or a message of some kind. And they can be great in terms of they're found almost everywhere in software, and they've been heavily relied upon by developers to help understand our system behavior. However, unfortunately, logs alone are not enough, because logs aren't extremely useful for tracking code execution, because what they typically lack is sort of contextual information. What is the context of that message? Why did it occur? Where in that particular path did it occur? What caused it? So this is why we don't just want to stop at logs. This is why we have more than one pillar. This is why we want to go beyond logs as well as utilizing them, but utilizing them with other information. Now, the nice thing about logs is that many different runtimes and frameworks offer this as standard. So, for example, OpenTelemetry, the runtime that we're going to be using today, has a unified logging component that handles messages that are written by the application. And it provides things like first failure data capture, and you can utilize things like system out and system to be able to combine the server logs. So there is ability to be able to sort of automate this using the tools you're already making use of. So that's logs, but logs aren't enough by themselves. So then we've got metrics as the second pillar. And again, you may already be using this or you might not. Metrics are what we refer to as aggregations of numerical data about either the infrastructure or the application over a period of time. So the nice thing about metrics is that we can get, instead of just having a snapshot, like a warning or an error of this went wrong at this time, we get an idea of how our application is behaving over time, whether that be a long period or a short period. It gives us an idea of things like CPU utilization, request rates, memory usage. The nice thing about this is that these metrics, this data, is more malleable to mathematical and statistical transformations. So we can do things like sampling, aggregation, correlation, looking at trends and understanding that within our application. These make metrics much better suited to report the overall health of our system, rather than just that specific snapshot of a particular microservice, for example, that we get from logs. So how do we enable metrics? Well, actually, MicroProfile can be a great help for this. Now, looking at the poll, I've seen that many of you guys haven't heard of MicroProfile before, so I'm glad that I've got this slide in here. I see a lot of you haven't heard of OpenTelemetry either, so we're going to be covering that as well. So MicroProfile is a community-driven specification. It's open source, and it's a specification that really builds on top of sort of Java as a language. So it's built for people who might be building applications that utilize either Java EE or Jakarta EE, the sort of open source version of Java EE. And it enables key APIs and behaviors that are very important for microservice-based and cloud-native applications. The bottom row here has a lot of shared APIs with Jakarta EE, that open source Java specification. So you might recognize it if you're seeing things like CDI, JSONB, JSONP. Those are shared APIs because the communities actually work very closely together. But there's also additional capabilities in here, like, for example, the ability to have external configuration, enabling health and metrics within your application to be able to see how your application is behaving. Is it healthy up in the cloud? Enabling security through things like JSON Web Tokens, and enabling things like reactive messaging as an example. Now, the one we're going to be focusing on in this particular part is the metrics part, because obviously we're talking about metrics as this pillar here. So MicroProfile metrics is offered as an API to help with this. Now, the important thing to make note of here is that MicroProfile is a specification. So you will need an implementation to actually make use of it. But the nice thing about this is that because MicroProfile really is driven by the community and it's all open source, it's designed to be an open source standard, there's a lot of flexibility in which runtimes you can make use of. And what it means is you have that portability. So if you were to develop an application using, say, Wildfly, for example, you could easily move it onto something else like Quarkus or Liberty, because you're essentially utilizing the same underlying standards. So there's no vendor lock-in, which you might get with alternatives like, for example, Spring. So that's one of the advantages of making use of something like MicroProfile. And as you can see here, Liberty has some of the latest compatibility with the major versions of MicroProfile. And that's often because we actually help and lead many of the specifications within this open source framework. So in terms of MicroProfile metrics, this particular API within MicroProfile enables it's there to provide a unified way for us to export monitoring data, so telemetry, and sort of having that unified Java API so that we can all expose them in the same standard manner. So this can be a really great tool for utilizing if you're not already making use of it when it comes to that second pillar, metrics. However, although metrics can be really helpful, they aren't necessarily, combined with logs, going to give you an entire view of the whole application. The biggest drawback with both application logs and metrics is that they're system scoped. So it makes it quite hard to understand anything else other than what's happening inside a particular system. So it doesn't give us much information about sort of what happens over the lifetime of a path, for example. So this is where distributed traces can be really helpful in providing us that sort of further metric, that further data, that further telemetry past just being system scoped. So distributed tracing is a technique that addresses the problem of bringing visibility into the lifetime of a request across several different systems. And so that's why it's important that we don't just stop at pillar 1 and 2. We should also go to pillar 3, which is distributed traces. And this might be the one that you may not necessarily be making use of. So distributed traces, what is this? It's a monitoring technique that links the operations and requests occurring between multiple services. What it allows us to do is to trace, hence the name, to trace the path of an end-to-end request as it moves from one service to another. Importantly, it lets us pinpoint where errors or performance bottlenecks in individual services might be that might be negatively affecting the whole overall system. So really nailing down, where is my problem, why is it occurring, and what can I do to potentially solve that issue. Without tracing, it can be really challenging to exactly pinpoint the cause of performance problems in a distributed system like cloud-native applications. So it really helps us to improve the visibility of an application's health and enables us to be able to have accurate and effective debugging behavior that we can then also produce, that can be difficult to produce if we were to do it locally, for example. There are some key concepts that you'll need to understand when it comes to tracing. And this is sort of the pillar we're going to focus on mostly today. The first one of these is traces. So as the name suggests, a trace represents requests, and it normally consists of multiple spans. So you can see I've got a diagram example here. We've got several different microservices that make up part of my application. We've got the browser, the API web server, and a background task worker. And you can see each of those creates a span, and those spans combine to form part of this trace. What are spans? Well, spans are representative normally of a single operation on a request. They're essentially the work taking place on a service. Spans can describe very broad operations. So for example, it can be the operation of a web server responding to a HTTP request, or they can be as small and granular as a single invocation of a function. So it's quite a wide range of different types of work that a span can describe. And that trace is just sort of the end-to-end journey of one or more connected spans. Now, the span enables us to collect it usually contains a name, time-related data, it might contain some log messages and metadata to give us more information about what's really going on in that transaction. However, where we get a lot of the benefit from is this concept of context. So far we've identified the components of a trace, but we haven't described how these components are really linked together. And this is why context is important. So context is all about containing data that allows us to be able to identify which request that span is a part of. So it allows us to be able to sort of trace it back to understand, okay, what spans were part of this request and what order did they go in, so I can trace back throughout my request to understand, throughout my trace, to understand where in a particular request something went wrong and why. So when it comes to trace context, typically it's composed of two different values. We've got the trace identifier or trace ID, and we've got the parent identifier or parent ID. You can see it on the diagram here, which I've included in the purple. So the trace ID is a unique identifier that's generated in the root span, and really it's intended to be able to allow us to identify the entirety of the trace. So it's shared throughout that whole trace so that we can know which spans are a part of that trace. This is the same trace identifier we introduced in the last section. It's just unchanged to every downstream service. We've also got the parent ID. So this allows us to basically understand what was the span or the request before this. So the span ID is essentially the ID of the parent span that spawned that current operation. So you can see in my example here, we've got, so for example, the parent ID you can see in between where we have the queue is the same as the span ID of the parent span, essentially the one that was before that one. So what this allows us to do is with this combination of trace ID and parent ID, we can determine the originating root service and then reconstruct all our parent ancestor services in order that led to that current operation, giving us fantastic insight into exactly what's going on in each request and understand and be able to pinpoint where potential issues are occurring. So that can be really helpful when it comes to that visibility in such a complex, convoluted, distributed environment. So that's the theory. That's what we're trying to achieve. We're trying to achieve this distributed tracing. But how do we go about achieving that? And there are some open source standards that we can make use of for this. In the past, the way in which code was instrumented would vary a lot, because observability backends would have their own instrumentation libraries and agents for emitting data to the tools. What this meant for developers was that there was no standardized data format to be able to send data to a backend, to an observability backend. So if a company chose to switch observability backends, it meant that we'd have to re-instrument all our code and configure brand new agents just to be able to admit telemetry data to the new tool. So it became quite frustrating, took a lot of time and resources. So to tackle this, essentially there were open source communities and projects looking at, can we create a single standard that we can all use to be able to avoid these issues and resource usage unnecessarily? And so this is sort of where OpenTelemetry comes in. So OpenTelemetry offers a pluggable architecture that allows you to add technology, protocols, and formats easily. It supports various different metrics formats like Prometheus, for example, to allow you to be able to store and query metrics in a variety of different backends. So it's not specific to one observability backend. You can link it into many others like Jaeger, Zipkin, whatever it is that you're using. Originally, it came from two different standards. So originally we had the Open Census and the Open Tracing projects. Now the issue with this is that, as you can tell, Open Census, Open Tracing, that's two. That's not one single standard. So we still had this issue because although Open Tracing provided a vendor-neutral API for sending telemetry data to a backend, it relied on developers to actually implement their own libraries to meet the specification. Open Census, on the other hand, provided a set of language-specific libraries that developers could use to instrument their code and send it to any backend. So the best bits of these projects were combined to be able to create one single standard, OpenTelemetry. And you can check out the OpenTelemetry website, which is opentelemetry.io, to see this. This is it's a collection of tools, APIs, and SDKs. And it's actually within the CNCF Foundation. So it's an incubating project. In this, it's actually the second most contributed to, just below Kubernetes. So it's a very popular community that's being actively developed. So it's a really exciting space to check out. One thing to note with this, OpenTelemetry is a fantastic tool to utilize to instrument your applications and systems, so collecting that data. However, it is not a full end-to-end observability backend. We still need to plug it into additional tools for step 2 and 3 that we talked about earlier, storing and analyzing and visualization of that data. So we need to link it into things like Zipkin, Prometheus, Grafana, whatever it is you might be using. So make sure that you understand that it doesn't provide that end-to-end backend service. We do still need to plug it into other things, but it is a fantastic tool for that instrumentation. It looks a little bit like this when we take a look at sort of the architecture. So we've got our microservices at the top here. We might have some shared infrastructure. In the middle, we've got our OTel collector. That is our vendor agnostic implementation on how to receive, process, and export that telemetry data. Normally, it's a single binary that can be deployed as either an agent or a gateway, for example. And it allows us to be able to collect all of that data in one place and then send it out to whatever observability backends we might be using, for example. We're actually utilizing OTLP here. That stands for the OpenTelemetry Protocol. This specification describes the encoding, the transport, and the delivery mechanism of telemetry data between various different telemetry sources and intermediate nodes like collectors and backends. So that's what we're making use of here. Taking a closer look at the OTel collector. So as I mentioned, this is a vendor neutral, so vendor agnostic implementation on how to receive, process, and export our telemetry data. What it does is really help to remove the need to run, operate, and maintain multiple different agents and collectors, which is what we previously had to do. This helps us with things like improved scalability and helps to support open source observability formats. So it uses things like, it can use Jaeger, Prometheus, FluentBit, lots of different data formats, depending on what you're making use of already. And allows us to be able to send that to one or more open source or commercial backends. Whatever our choice is, it gives us that flexibility that we need in the cloud and that portability. You can see in here that we've got some of these like processes inside. Like, for example, it allows us to help with things like batch processing. It might have filters in there, for example. And really, you might be wondering sort of why, under what circumstances would you use a collector to send data instead of just having each service send data directly to the backend? Why do you need this? So we would say, like, for trying out and getting started with OpenTelemetry, sending your data directly to a backend is a great way to get value quickly. In development or in small scale environments, you can get fairly decent results without a collector. However, in general, we'd recommend using a collector alongside your service because it allows you to be able to offload data quickly, and the collector can then be in charge of or responsible for taking care of additional sort of responsibilities, like handling retries, batching, encryption, or even sensitive data filtering. So it allows you to be able to offload that from your individual services and have a central location for that within the collector. So it can be a really helpful part of that architecture. Now, OpenTelemetry is a specification. So again, we need some implementations to be able to make use of this. And MicroProfile actually implements the OpenTelemetry specification through one of its newest APIs, MicroProfile Telemetry. So this only came out in the most recent major version of MicroProfile this year, which is MicroProfile 6. I believe we're now on to MicroProfile 6.2, but this is still the most recent major release. And this adopts the OpenTelemetry tracing element. So the important thing to note here is that OpenTelemetry includes tracing, metrics, logs, lots of different elements. Now, MicroProfile has chosen just to implement the tracing element of this. And that's because there are some complications around the fact that we already have MicroProfile metrics. However, it is hoped in future that MicroProfile will pick up more of the OpenTelemetry sort of subcategories like metrics and logs, etc. So it is hoped that it will evolve to include those. However, right now it is just the tracing element. And it's designed to be able to, again, help with the creation and the management of our telemetry data. There's 3 different ways that we can instrument MicroProfile telemetry: automatic, manual, and agent. In automatic instrumentation, if you are already making use of Jakarta RESTful Web Services and MicroProfile REST Client, so 2 of those APIs from those open source specifications, you can automatically enlist those microservices in distributed tracing. You don't even have to do any code changes. You will automatically get those traces through. If you want to do some manual instrumentation, so let's say you want to add some annotations to a particular microservice that might not be using RESTful Web Services or MicroProfile REST Client, you can utilize CDI injection, or you can utilize annotations like @with_span. With CDI injection, you can utilize the annotations @inject_tracer or @inject_span, or use programmatic lookup. So there's various different ways we can enable that manual instrumentation as well. CDI is another API that you can make use of from Jakarta EE and MicroProfile specs. Then we've got the agent instrumentation. So this allows us to be able to use the OpenTelemetry Java instrumentation project to be able to gather telemetry data, again, without any code modifications. What it looks like in reality is a little bit like this. So we've got 2 microservices here hosted on OpenLiberty, and we're creating some spans from those, which are combined to be able to create a trace. We're then utilizing the OTLP specification to collect that data, sending it to a backend, either Zipkin or Jaeger, and utilizing a UI to be able to understand and see those traces. So this shows sort of what it might look like in reality when we're running an application, to be able to monitor the requests and the paths between those various services and sort of what's going on in reality. So that's OpenTelemetry and MicroProfile and how we can make use of it. Now let's check out how we can actually do that in reality. So we're going to check out a demo in this one. For this demo, we're going to be making use of OpenLiberty. Now, I noticed in the poll that many of you have not heard of OpenLiberty before, so I definitely check out the OpenLiberty website, which is openliberty.io. I've also created an article, which there's a link to in the resources section or at the bottom of these slides, which is called Why Cloud Native Java Developers Love Liberty. The nice thing about Liberty is that it is a modular runtime, so it's really lightweight and it allows you just to add the features and functionality that you need in your application to keep costs low when you're deploying it to the cloud. It really focuses on code and on development, allowing you to make very fast and iterative changes. We have something called dev mode, which we'll take a look at in this demo. Dev mode allows us to be able to run our application in development mode, essentially, allowing us to, essentially, we build our application and our application is able to actively watch for changes to our code and configuration and then automatically rebuild and recompile our application so that we can see those changes in real time. So allowing very fast, rapid, iterative development. It's also been built to be able to help us write effective tests. So we have lots of different test frameworks that we enable with OpenLiberty. We've got the usual suspects like JUnit and Arquillion. We've also got some newer, exciting projects that we integrate with, like test containers, that you might see some talks on as well. And as well as that, it's ready for containers. And as I said, not in your way tools and flexibility. Pick the features that you care about and make sure and it allows your application and runtime to stay as small as possible while still being very performant. So check out the article if you want to see more information on OpenLiberty, but that's the runtime that we're making use of today. For this demo, we're going to be making use of some of our interactive guides. So if you've not checked out OpenLiberty before, I've put a link to the Liberty website and specifically to the guides section and specifically to the observability section within that. We have over 50 guides, all targeting different technologies to help teach you about those APIs and those technologies with OpenLiberty. The nice thing about these guides is that they only take sort of 15 minutes, roughly 15 to 20 minutes, depending on the topic. So you can get them done fairly quickly. And the nice thing is that they just focus on that one particular technology with a very simple application to help you learn that in a very quick and effective manner, rather than trying to play around with a huge enterprise application and figuring out the technology as well. We've worked really hard at these, so we would really love for you to go and have a go with them. Let us know your thoughts. They are all open source, so you can check out the GitHub repository that sort of is behind them. You can either run them locally or you can run them in our cloud native environment. So we've also worked really hard on this. Essentially, the nice thing about the cloud native environment is that all you have to do is utilize a browser. So by using the browser, you can essentially have an environment in which you don't need any prerequisites downloaded locally on your own machine. You can get started straight away with our IDE in here. It's based on the open source Thea IDE. So it allows you to have all the instructions, the IDE and the terminal, all in one browser, all in one place, easy access to this technology and no prerequisites on your local machine. So definitely a great place to get started, especially if you've got restricted access on your machine and you can't just go ahead and download whatever you want. This is a fantastic way to try out these technologies in a safe environment. So this is what we're going to make use of today in our demo. Yay, it's still working. Fantastic. Okay, so I have this demo up and ready already. So essentially what I did was I went to the OpenLiberty website. You can see all of our guides here. We've got a huge selection, 42 plus 11 plus 11. So yeah, over 60 actually now. And if you're interested in a particular topic, then please feel free to use our menu or you can search using our search bar here. Now, because this is an observability presentation, we're going to the observability section. And the guide that we're going to be doing today is this OpenTelemetry one, because this is the topic that we're focusing on. So when I click on that, it opens up this tab here, which is essentially the guide that we're making use of today. If you want to do it on your own environment, your own machine locally, absolutely fine. Just bear in mind that you will need these prerequisites on your local machine. So make sure you have them. We'll always include them in the top right. And then you'll need to scroll down to get the instructions. And as you go through the instructions, code will appear on the right-hand side of what you need to essentially have in your application, as you can see here. So that's how to do it locally. But we're going to do it in the cloud native environment. So to get there, you'll need to click this Running Cloud button, and that will open a new tab, and you'll have to click again this Access Cloud Hosted Guide button. You will need to log in Previously, we didn't have a login. However, unfortunately, Bitcoin miners decided to take advantage of that. So we've decided to put a login now to sort of stop that from happening. So it is a social login though. So hopefully as developers, you will have at least one of those login options. GitHub is one, so that's what I use to log in, but also things like LinkedIn, or you can create your own login with your email. So it's fairly easy to get started. When it loads, you'll see a screen a bit like this. Please let me know if this font isn't big enough and I can zoom in a little bit more. But essentially what this is instructions. Cool, got some thumbs up. Thanks, guys. Instructions on the left-hand side. And then on the right-hand side, we've got the IDE that I was talking about and the terminal. So I've already gone ahead and I've already started some of these instructions in the interest of time. So in this, you'll get the first page, which sort of introduces, okay, this is a guide about OpenTelemetry. Great. You'll then get this page, which takes you through what you'll learn in the guide. I've already covered a lot of this in my presentation, so we're going to skip this for just now. But essentially what it looks like is this gives you an architectural diagram of what we're going to be utilizing as the application today. Most of our guides use the same application to try and make it easy for you if you're trying to find out multiple technologies and trying multiple guides, because then you don't have to worry about understanding the application because you've already seen it before. So this is a very simple application because we're trying to keep it as simple as possible to make it easy to learn. It consists of two microservices. We have the system and the inventory microservice. The system microservice essentially scrapes data from your system every 15 seconds, and the inventory microservice receives that data and stores an inventory or a list of all your systems and that system data. So the two work together to create this overall application. So fairly simplistic, but good for us to get started with. So as I said, I've already gone ahead and started some of these instructions. So I made sure that I was in the right directory, and I did a git clone on our GitHub repository and just CD'd into the right directory, in this case, our guide. If you do want to check out the guide itself, as I said, all open source, so feel free to check it out on GitHub. You can just follow the link that we have in the instructions here to check it out. Now you'll notice if I go into our sort of file structure or directory structure, you'll notice that we have a finish directory and a start directory. We have that in all of our guides. The start directory is where we're going to start from, and it's it's like a half-finished application because we want it to be half-finished so that we can follow the steps to actually learn the technology. The finish directory, on the other hand, is what we should get to at the end of all of these instructions. So the nice thing is you can try out the finish directory before you start going through the instructions, so you know what it's like and what you're supposed to get to at the end. You can also use the finish directory if you hit any bugs or errors that you might have introduced and be able to compare it to the code in there to know where it might have gone wrong. So sort of a reference there for you to take a look at. But we're going to be going into the start directory because that's where we're going to start from with all of these instructions to show just how easy it can be to add observability using microprofile telemetry. So I'm just going to close this Explorer view so we can see more of the IDE. Now, we do need to use this Docker command first to be able to get Jaeger up and running. This is the backend we're going to be using. So I'm just going to clear this so it's a bit easier to see, make this a bit bigger for you. So essentially what this Docker command is doing is getting Jaeger up and running. In this case, we're using Jaeger. You could use Zipkin. As I said, lots of different backends that you can plug this into. We're just using Zipkin in this case as an example. Fantastic. So that's got up and running fairly quickly. So before we proceed, we need to make sure that that is up and running. So I should make a note that for all of the commands that we have in these instructions, we have this execute button. So it makes it really easy to be able to, if you press the execute, it will automatically execute in the terminal you have open. You can also use this copy button to manually copy and paste it, or you can manually copy and paste it yourself. But hopefully these buttons make it a bit quicker and easier. These buttons also allow us to be able to open pop-ups. So if you don't see anything, make sure that you don't have pop-ups blocked. I often get that message. So now when I click on this, I get the Jaeger UI, and you can see it's all up and running, so that Docker command worked successfully. In the instructions, we do tell you to go to the finish directory to try it out. We're going to skip that in the interest of time and just go straight into, okay, how do I add observability? The first thing we're going to do is build our application before we start adding it in. And we're going to be using dev mode for this. So I'm going to be seeding into, in this case, my system microservice. You can see in my directory structure here. And I'm going to be starting it with Maven Liberty Dev. If you prefer Gradle, you can also use Gradle with OpenLiberty. If you really want, you can use Ant. But in our guides, we tend to stick to Maven just to have consistency, and so that you don't have to keep learning new build tools with the different guides. So that's why we're using Maven in this case, but you can use Gradle as well. So this is, as I said, for the system microservice. We're also going to need to do the same for the inventory microservice. Now we're running this in dev mode. So what that means is we're going to be able to actively listen and watch for those code and configuration changes. We know that it's up and running and ready to go when we see this line of stars and this text, Liberty is running in dev mode. That's when we know, okay, that microservice is up and ready to go. So I'm going to go to terminal, new terminal, to create a new terminal down here, because now this other terminal is in use watching for those file changes because we've run it in dev mode. So we need a new terminal now. So I'm going to do the same thing, but this time with the inventory microservice. So I'm just seeding into that inventory directory and again, running that Maven command to get Liberty running in dev mode. So again, we're going to be watching out for those configuration and code changes. And this is where you can get that really iterative, agile style development, which can be really helpful, especially locally on your own machine. Again, what we're looking out for is this line of stars with Liberty is running in dev mode. And when we see that, we should know that it is up and ready to go. Cool, there it is, perfect. So there it is. Liberty is running in dev mode. So now when we see both of those, we can open up a new terminal again to be able to do these curl commands. So this first curl command is essentially to find the system service. So if we enter this, yeah, fantastic. You can see some of that system information here that it's scraping. And we can also do the same with the inventory microservice. Cool, at the moment we don't have any systems because it only gets sent through every 15 seconds. So how do we actually enable, now that we've got both microservices up and running using dev mode, how do we enable adding telemetry in? So as I said, we're going to start by navigating, I'm just going to clear that, to the start directory, just to make sure that we're in the right one. Let's see where I am. Cool. CD into that, and then into start. Great. So now that we're in the start directory, we can now start with adding in the necessary code. The first thing we need to do is enable the microprofile telemetry feature in the server.xml configuration file. Using these buttons, you can very easily and automatically open up the files that you need to edit in the IDE, or alternatively, you can navigate through the Explorer view if you'd like to do it that way. We've provided all the code you need. You can just copy and paste and replace everything in that class. Alternatively, you can look through and find the differences yourself. It's up to you. So you can see in this case, we're enabling this feature, microprofile telemetry. We've also got some of the other microprofile and Jakarta specifications or APIs in there, like JSON-B, JSON-P, CDI, RESTful web services like we were talking about. So they're also enabled. Remember, this is all about modularity and ensuring we're lightweight. So we only want to have the features that we're actually making use of in here. So that's why we're now adding microprofile telemetry. Make sure that you also save your files as you change them. There is an automatic saving in this IDE. So you can either go up to File, Save, or you can use the shortcuts on your keyboard, either way. So that was for the inventory microservice, for the system microservice. We now need to do the same for the inventory microservice. In this case, we're also making use of another feature, which is microprofile config. So again, you can just add that feature in, or you can copy and paste the whole class over. I'm going to do that just to make sure I'm not introducing any errors myself. So now that we've enabled those features, we now need to make sure that we turn microprofile tracing on. It's a little bit odd, but for some reason, microprofile telemetry is off by default. So we need to enable it with some additional configuration. So we're going to create a microprofile config properties file. So you can see that's where we're making use of this API from microprofile config, which allows us to have external configuration files within our application. So to do that, I'm just going to run this command, this touch command that allows me to create that new class or that new config file. And we're going to open it up. It's empty right now because I've only just made it. And I'm just going to copy and paste in these two different config values. These config values allow us to set the the name of the service that this is for. So in this case, it's for the system microservice. And this value here allows us to change the default so that open tracing is on, OpenTelemetry is on. So by setting it as false, we're now enabling tracing. A little bit backwards, but just something to get our heads around. So now we need to do the same thing for the inventory microservice, because this is for the system microservice. So I'm going to create that file, open it up, and copy and paste those in. You'll notice the only difference here is the name. So now we're changing this to inventory, because this is now for the inventory microservice. So we've got the same false here to enable it as well. Okay, so now we can run the system and inventory services. So we're going to use this curl command to be able to do that. There we go. We can see some of those logs coming through. So now, to view the traces, we're going to go back to our Jaeger service. You can click that button or just head back to the tab you've already got open and refresh. And now what you'll see is my services are starting to appear. So I've got inventory and system. So if I click and find traces, you'll notice that even without any code changes, just by enabling a few small changes in our configuration, so that feature in our server.xml and that those two values in our microprofile config properties file, I've already got traces coming through because I'm making use of that automatic implementation, because I'm already making use of Jakarta RESTful Web Services, which you saw as one of my features. You can then click into that and gain additional information on those traces and the spans within them. So really gaining in-depth information here on what's going on in our application. So you can see in just a few minutes, I've already gotten started with enabling OpenTelemetry. Just checking the time. Cool, we still have some time. So the next step in this guide is to check out how to enable explicit distributed tracing. So automatic instrumentation only instruments Jakarta RESTful Web Services and microprofile REST clients. If we're not using those, or we want to go further than that, we can essentially add the manual instrumentation to our source code. And that's what we're going to be doing in this next step. So in order to do that, we need to replace our pom.xml file because we need to be able to add in our, let's just double check. Yeah, so essentially what we're doing here is making sure that we have the OpenTelemetry API and OpenTelemetry instrumentation annotations in our build path, because we didn't currently have them before. So that's what we're adding into our pom.xml. So we can open that up. And again, you can just copy and paste, or you can find the ones that are new and manually do it yourself. So in this case, if we scroll down, we can see we've got Jakarta, we're using Jakarta EE, we're using microprofile, we've got some testing frameworks here. And then if we scroll down further, we're also making use of the OpenTelemetry tools. And so we're adding in, did I go past it already? I might have gone past it. Let's just double check I've got the right one in there. Save. Yeah, that has saved. Let's just double check. So we are adding in the OpenTelemetry API and instrumentations in the pom.xml. They're in the IO OpenTelemetry dependencies, which I'm struggling to find in this small, like I'm so zoomed in. Let's just double check that that has worked properly. Ah, okay, right. It's because it's not copying everything. Okay, let's manually. Okay, I'm hoping that's going to work, but we'll have a look in a minute. Let's just see where it's changed in here and double check that we've got that in our application. Otherwise, it's not going to be good when we continue. There it is, dependency group ID. Up near the IO telemetry. Yeah, see, I think it should have been just below Jakarta EE. But we've already gone on to tests. So for some reason, that's not copied across correctly. It might just be that my UI is not copying it correctly. Let's try again. Ah, okay, this is not letting me edit it. Let's try and go up. Open up pom.xml. Okay, let's try again. Live code. Always something going wrong. Fantastic. Okay, so yeah, there we go. So now we have the OpenTelemetry in our build path. Perfect. Glad I got that working before we continued. So now I also need to go into the server.xml in the inventory service and make sure that I have the appropriate features in there as well. So if I copy and paste that over, essentially what I've gotten here is I'm adding in this ability to be able to expose OpenTelemetry APIs as third-party APIs in OpenTelemetry. What this allows us to do is to add visibility of the OpenTelemetry APIs to the application by adding third-party to the types of API packages that this supports. So instead of explicitly configuring a list of the various different API packages, I just want to set plus third-party value to the API type visibility. So that's what we've done here. You can see API type visibility plus third-party to be able to enable that. Okay, so now we're going to enable tracing in Jakarta CDI beans. So we can trace our Jakarta CDI beans by annotating their methods with an @span annotation. So for this, I'm going to open up the inventory manager class. So this is in our inventory microservice, remember. I'm going to copy and paste that over. Okay, my commands aren't working again. Let's try and open that up again. Let's close that and open it again. There we go. It's just getting a bit stuck at the moment. So let's copy and paste that over and save. So what we're doing here is with the list and the add methods, we've annotated them with, so here's the list and here's the add. We've annotated them with this @span annotation. Microprofile mostly works with annotations. So if you're familiar with other microprofile APIs, you'll be familiar with this style of sort of adding annotations into your application source code. What this allows us to do is to accept an additional parameter, an optional parameter that functions as the span name. So you can see we've added that in here. So in the list method, this is automatically generated through the instrumentation. We can also specify a custom span name. So for example, inventory manager add is specified here. So in the list, we're just leaving it to default, but here we're specifying the span name that we want it to use. The OpenTelemetry instrumentation then provides a new span for each of these methods. So now that we've got this annotation, we can collect and trace these spans as they go across different services. Optionally, we can also include parameters like, for example, @span attribute, where we can specify things like the host name or the host parameter, which helps the trace parameter with the add span. To learn more about this, you can go and check out the OpenTelemetry documentation if you want to. But what we're going to do is just hit this curl command so that we can see this new manually instrumented trace actually in our Jaeger UI. So what we want to do is refresh our Jaeger UI. Let's go back to the UI, inventory, and then find traces. And what we should see, let me have a look if this went through correctly. Yep, so we'll see 2 spans. So if we go into that, and what we should see is, I need to do the second one. So to check out the information that we generated with the @span attribute, we have to run this other curl command. That's why we're not seeing it yet. So now if we go back to the Jaeger UI and refresh, and then inventory again, let's just double check. Yeah, so we should now see 4. So let's have a look. What have we got? It's not appearing here. Let's try and find it again. There we go. So we have that additional one that we've got in here that we didn't have before. So you can see how, again, in just a few minutes, I know we had some technical glitches with the UI for a minute, but you can see that we can also easily add additional instrumentation using that manual and annotations into our application code as well. In the interest of time, I'm going to stop the lab there, but there is more to it. If you want to check out how to use a custom tracer object, for example, that's the next part of the guide. And we also take a look at testing the application as well. Now note that if you're using this environment, you will need to clean up after yourself. So you'll need to do these Docker stop commands and clean up your environment as well, because it does save the environment as you go between different guides. So make sure you're cleaning up if you're going to do multiple guides all in the same session. It will automatically log you out after half an hour of inactivity, and that will essentially wipe clean anything you had in there anyway. So just to bear that in mind if you're going to try multiple of the guides. Okay, so with that, I'm going to just wrap up so that we have some time for questions. So in summary, hopefully what I've shown you is that we are entering a world of increased complexity, but that effective observability is critical for us to be able to monitor and understand how our applications are behaving and performing in this very complex and convoluted environment. It's important that we enable that portal, that looking glass, for us to be able to step through and understand what's going on in the cloud. However, the nice thing is that I know it seems like a lot, but you're not alone. There are many different open source tools and communities that are there working on this problem and enabling tools and standards like OpenTelemetry that you can take advantage of. And you can make use of things like microprofile and OpenLiberty to be able to make use of this in your own applications. As I said, I did have some resources. So if you did want to click on the resources tab, I've included several of these there. Otherwise, they are in my slides as well. So if you want more of a recap on what is observability, check out the first link. The second link is more around, a bit of theory and background on what OpenTelemetry and microprofile are and how they work together. And the third one is a blog version of the tutorial I've just taken you through from our OpenLiberty blog. If you are interested in learning more about OpenLiberty, please do go ahead and follow us on LinkedIn and Twitter. I've also included links to these in the resources tab. I run these, so I'd love for you to come and join and chat with us and share your thoughts, especially if you try out any of the guides. We do work hard on them, so we'd love to hear your feedback on whether they're useful or you enjoy using them. So please do check us out on LinkedIn and Twitter. But with that, I'm going to say thank you so much for listening to this presentation and for joining me here today. Please feel free to follow me on Twitter or LinkedIn, either one, if you have additional questions or you want some more resources to do with this subject. Thanks so much. I'll check out your questions now.
Thank you so much, Grace. Thank you so much for that very informative session that you gave our participants. So definitely they enjoyed it, and I can see that through the emojis and all the reactions in the chat earlier in your session, they're very agreeable to what you're saying. So we have a couple of questions here posted for you. Let me read some of them from JC. What role is the main responsible or accountable for observability on the cloud? What will be the boundary between DevOps, security, and dev?
I feel like we could do a whole presentation on just this question. That is a great question. What I would say is this really is it depends answer. I'm going to take the consultancy approach here because really it depends on your organizational structure, your team structure, how your application is built and developed. There is a growing trend towards development teams taking on more of the ops responsibilities, and that includes things like observability, deployment into the cloud. So many teams are moving more towards this being the responsibility of the development team. However, larger organizations that perhaps have more resources might have a dedicated DevOps team. And so they might be responsible for the observability. But what I would say is when it comes to instrumenting the application, which is what we focused on in this presentation, that I would say is generally down to the development team, because it's the development team creating those classes and creating those applications. So it's up to them to enable data to actually be collected. Whether they're in charge of looking at the Prometheus dashboards or the Grafana dashboards, that would be another question, I would say. But definitely instrumentation, it should be the primarily the responsibility of the development team. But again, differs depending on if you're in a startup versus a very large enterprise. Very different development environments.
All right. Thank you for that question, JC. I hope Grace answered your question. We have another question from Ryan L. Can OpenLiberty be used on monolithic type of application?
Yeah, so the great thing about OpenLiberty is that it actually stems originally from Liberty, which also stemmed from WebSphere. So if you're familiar with WebSphere, you'll know that it's a fantastic tool for more traditional monolithic style applications. We realized that actually it was a bit heavy and clunky to be run on the cloud. So we created Liberty, which was really designed to be that modular, lightweight runtime. And then we open sourced that in 2017. So the nice thing about Liberty is that it supports a huge range of different architecture types, ranging from monolithic through to maybe more like macroservice, if you're not going all the way down to microservices, all the way down to function style applications. So it does support a wide range of applications because we have clients who were previously using WebSphere who are now moving on to Liberty, who have more monolithic style applications. There's not one right answer when it comes to architecture. So we do support a range of them.
All right. Thank you, Grace. And thank you, Ryanel, for your question. We have another question from Jed Aliado. Is there a suggested or a best practice on where logs should be placed, or is it a case-to-case basis?
It is a case-to-case basis. I would say utilizing things like system out, system not relying on like local caching, for example, for your logs, making sure that you do have a sort of persistency for those logs that will go beyond, say, the microservice so that you can access them. But also, not relying on local caching. It definitely is it's a case-by-case basis because it depends on the application, what the log is for, what you're using it for. Is it just a log for your development? Is it needed in production? Are you including it as part of a trace? As part of a span, for example. So really, it is a case-by-case basis, I would say. But there are some recommendations out there.
All right. Thank you, Grace. Thank you, Jed. And our last question has actually been answered by the person himself. So, guys, for those who upvoted the question, because he's asking for the site for the sandbox. So, guys, for those asking the site for the sandbox, he actually posted it in his comments for the question. All right. Are there any more questions left? Or if none, maybe we could say goodbye and thank you to Miss Grace Jansen. Thank you so much once again, Miss Grace, for gracing us in this year's SoftCon 2023. Once again, thank you for sharing this beautiful presentation to us. And I hope our participants got a lot of new learning from you and this presentation. And guys, thank you so much for joining us for day 2 of SoftCon. But before I let you go, let me just share a few reminders for all our participants. Again, did you know that there was a leaderboard? So if you would like to check the leaderboard standings, the leaderboard icon is on the top right again. And so that's why we encourage you the entire day to participate and engage in all the functions here on AirMeet, which still continues to accumulate points even tomorrow for our last day on site. So once again, you can win prizes for the top 3 in the leaderboard for tomorrow. You will learn the winners by the end of tomorrow. So that's tomorrow afternoon. And last thing for our hybrid ticket holders, gates open at exactly 7:30 a.m. at the SMX Aura Convention Center. And our virtual ticket holders, we will start our live stream at exactly 8:30 a.m. So let's see each other tomorrow. And thank you once again for joining us for day 2. And let's enjoy the rest of SoftCon. Thank you, guys.